All right, our next lesson after we've learned to create redox tables is we're going to get into predicting redox equations. So this begins on page 21 in your workbook, and you'll see a table that looks like this. It says aqueous solutions of tin 4 nitrate and iron 2 iodide react. So we're going to be using these tables to set up our equations each time. A few hints for filling this out. So here's a few things we need to do is list all species present, our strongest oxidizing agent, strongest reducing agent. Then we find our half reactions, our net redox, and then we predict whether it's spontaneous or not. A couple hints for labeling this. So this is just right out of your textbook. If it's an aqueous solution, make sure you include liquid water as one of your entities present. Entities just means list anything that's there in the reaction. If it mentions an acid, then you need to include hydrogen. If it mentions a basic solution, then you need to include hydroxide. Okay, some oxidizing reducing agents are combinations of both, so we'll see that when we look at the data book. And some entities can act either as an OA or an RA, so we need to make sure we label those as well. So here's a table that I will have you copy into your workbook. So at any time you can pause this video and copy this out. It's on bottom of page 21 in your workbook. So using this chart as a guide, so step 1, we list all our entities present. We're going to go back to that first initial example. Keep in mind that if it has the potential to act as both an OA or an RA, you're going to see it appear on both sides of your redox table. So something like water, for example. Now we're looking for water just by itself. So this is a combination of manganese and water, but we're looking for the one that just has water by itself. And there's a couple. We see water on both sides. So here I have H2O liquid as an OA, but if we scroll up, we'll find water as an RA. So there are certain entities that are able to gain or lose electrons. Those we have to consider OAs and RAs. So let's go back to our first example. And we're going to list all the species present. So aqueous solution, as soon as I see that word aqueous, this tells me that I've got liquid water present. So I've got H2O liquid. Tin 4 nitrate is an ionic compound, which is also soluble. So we're going to dissociate this into the individual ions. So this will be tin 4 plus aqueous. And we're going to also have nitrate ions, which are aqueous. And then iron 2 iodide is also a soluble ionic compound. So we're going to dissociate that into Fe2 plus and I minus, both aqueous. Go through first and label anything that can act as an OA. And I like to put all the OAs, I like to label across the top, and then RAs, I like to label across the bottom, just so we don't mix them up. So water, this can act as an oxidizing agent. Tin 4 plus can only gain electrons. So remember, gain electrons, reduction, this is our OA. So this will act as an OA. Nitrate is an OA. Again, if you're not sure, check your table and see which side it appears on. If it appears on both, then it's both an OA and RA. So we're going to be checking here. Nitrate is an OA. Iron 2 can also act as an OA. And I negative is not going to be an OA. This can only gain electrons, or sorry, it can only lose electrons. So now we're going to go through and label the RAs. Water is one of those that appears on both sides of that chart, so this will be an RA. Tin 4 will only act as an OA. Nitrate will only act as an OA. Iron 2 can be an OA or an RA. And then I negative is an RA. Now we have to identify the strongest oxidizing agent and the strongest reducing agent. Here's where we go to page 7 in your data book. And we're going to start by identifying the SOA. So remember, the top corner, F2, this is our strongest oxidizing agent. So of the oxidizing agents I had water, tin 4, nitrate, and iron 2+. What I'm going to do is scan this page in my data book, and I'm going to look for the one that appears first. So I want to scan through the chart, and we're looking for any of those 4 OAs. So what I even do sometimes is just, take a separate sheet of paper and just kind of scroll it down like this so we can see which one comes first. So when we do that, we're going to end up seeing the tin 4. So this is the first one that appears. Everything else is below it. So that's going to be our SOA. So the SOA, it is the tin 4+. The SRA, we're going to do the opposite. So our RAs, we have water, iron 2, and I-. Go to your page 7 again. This time we're going to start at the bottom. So remember, your strongest reducing agent is the bottom corner of your page 7. So lithium, for example, this is the strongest one in our table. So we're going to start from the bottom and work our way up and see what is the first thing that appears between the water, the iron 2, and the I-. So if we just scroll our way up, scroll your way up, here I see I-. Okay, right here with the silver, but it has to be by itself. I don't have silver as part of my reaction, so this is not going to be the SRA. If I keep going, here I see 2I-. This is the first one that we're going to come across. The next one would be iron 2, and then much further up to the top is water. So the lowest one on the RA side of it is the iodide ion. So this is going to be my SRA. So I-. Now we want to come up with our reduction half reaction and our oxidation half reaction. So my SOA, the strongest oxidizing agent, gets reduced. Another way I remember that is the acronym SOAR. Strongest oxidizing agent is reduced. So I've got tin 4, and this is a reduction reaction. If we look up tin 4 on our chart here, there's tin 2. So if we go a little higher, we should see tin 4. So tin 4 is going to gain 2 electrons to become the tin 2 ion. So this is our reduction half reaction. And then iodine, okay, this is our oxidation half reaction. Remember that we read it backwards. So we read it from right to left to get the oxidation reaction. So I've got 2 iodide ions, and it's going to lose 2 electrons to give me solid I2. If we look, I've got 2 electrons on each side of the arrow, so I can cancel those out. My net redox equation is going to give me tin 4 aqueous plus 2I-, and this will produce tin 2 aqueous plus iron 2 solid. The last step is we predict the spontaneity. Is it spontaneous or is it non-spontaneous? So take a look, go to your data book, find your SOA, which is tin 4, and find your RA, which is I-. Tin 4, the OA is below the RA. So if we think back to our spontaneity rule, remember that if the OA is above the RA, it's spontaneous. But if the OA is below the RA, it's non-spontaneous. So in this case, because the tin 4 was lower than the iodide ions, this is going to be a non-spontaneous reaction. So if we go back and review our steps, our first step is to list all the entities present, whether they're atoms, ions, or molecules. Elements and molecular compounds always have no charge, and they always remain in the molecular element form. Just something to point out, because that example didn't come up in the last time. Okay, step 2, we identify the SOA by scanning from top down on page 7. Then we identify our SRA from scanning the bottom up. Our fourth step, which didn't come up in the last question, but will come up in the next example, is if the electrons aren't balanced with each half reaction, then we do have to balance those in order to cancel them out. So our fifth step, we predict the spontaneity. Let's take a look at another example. So this particular example is at the bottom of page 22 in your data book. So I've got a solution, aqueous, so right away I'm going to put water, of iron 3 chloride in a nickel plated container. So the iron 3 chloride is an ionic compound, it's soluble, so I'm going to dissociate that into Fe3 plus ions and Cl minus ions. The nickel plated container means that this is stored in a container made of solid nickel, which is a metal. So in this case, that's an element. It's just going to remain in its elemental form of nickel solid. Go back and identify all of your OAs, your RAs, and anything that could potentially act as both. So water can be an OA or an RA. Nickel 3 plus, or sorry, iron 3 plus, Fe3 plus is an OA. Cl minus, if we check our data sheet, this is actually an RA. So if you look along the left, or sorry, the right-hand column, you'll see Cl minus as an OA, or an RA. It's way up here. So Cl minus is an RA. And then solid nickel is also an RA. So I've got water and I've got iron 3 as my only two oxidizing agents. So start from the top and scroll down until you come across one of those entities. And the first one that we see is iron 3. It's higher up than the water. So this is going to be my SOA, the iron 3 plus. And then the SRA will start from bottom up. So if we keep scrolling up the chart, first one I see is nickel solid. So that's going to be my SRA. My reduction half reaction, so remember, the strongest oxidizing agent is reduced. So remember SOR, we've got Fe3 plus, and it's going to gain 3 electrons to become Fe solid. Nickel, solid nickel, is going to lose electrons to become nickel 2 plus. And to do that, we've got to lose 2 electrons. So here's an example where my electrons don't balance. So before I can determine my net redox, I have to do a little work so that the electrons will cancel out. So here I've got 3 and here I've got 2. So in order to cancel these, I have to make them both the lowest common multiple, which is 6. So I'm going to times this one by 3, and I'm going to times this one by 2. This should allow me to cancel out the electrons. So when I multiply everything by 2, this will give me 6 electrons in each one. 2 times Fe3 plus gives me 2 iron ions. 3 times nickel solid gives me 3 of these guys. 3 solid nickels. And I'm going to get 2 solid irons and 3 nickel ions. Now we predict the spontaneity. So go back to page 7. Here's my nickel. Okay, where's my iron 3? So let's see here. Here's iron 3. And here is solid nickel. So in this case, because my OA is higher than my RA, it is going to be spontaneous. If you try the example on the next page, example 2, you should come up with a net reaction of Cl2 plus 2 bromide ions. This is going to give you 2Cl minus plus Br2 liquid. This is aqueous, and this is a gas. So go through, list the entities present, identify the OA, RA half reactions, and you should come up with this as your net. And then I would like you to go to page 7 and locate your OA and your RA and see which is higher, predict the spontaneity.